Hi everyone, my name's Catherine with Capture 3D. Thanks so much for joining us today. I know it's been interesting times, but our team has come together to creatively put this program together. We have a new product to share with you. It's called the ATOS Q and it's in this box. It's an accurate blue light 3D scanner made by Go. So today we wanted to make it as interactive as possible. I know it's a digital format, but please use the chat. Our team members are online. They'll be answering your questions real time, and we will have a Q&A throughout this event. So we'll be unpacking, setting up the ATOS Q, interviewing different customers to get their input and feedback from the industry, and also giving you the tech specs so you understand why companies are adopting this technology from product development, quality control, manufacturing to production. So we're excited to share this moment with you. Thank you so much. Alan, let's get started.
Let's go.
I think it's most important for companies who are looking to kind of have their quality lab on the go, to be able to pick it up and carry it out to an assembly line on the tripod or anything like that.
You have that adaptability to move this around with ease.
I think it's super exciting getting that new technology at a good price point to people that probably didn't think they could get into something like that is super advantageous.
Anything ATOS is better than anything else on the market. So the fact that it's developed by Go I think it's gonna outshine anything in its class.
I'm really excited for the new ATOS Q because of the new price per performance in the industry for manufacturing companies.
Take a second and imagine you are a letter in the alphabet. What letter would you choose? Obviously Q, because Q stands for quality, and that's what the ATOS Q is all about.
I've been on a few service jobs with it, and it's amazing how portable it is and how light it is compared to the 5.
I see it fitting in well in almost every industry, whether it be in the metrology lab, the shop floor, incoming part inspection. I think it'll work great anywhere. And especially you have the ability to put it on a 4105 or put it on a cobot. So if you want a reasonably priced, fully automated system, that's amazing.
I think that they're going to be really impressed. The data quality that the Q spits out to the very edges of the measuring volume with the blue light equalizer is going to definitely impress somebody. You can't come away from a demo of this data and not be impressed by it, I think.
Hi everybody, my name is Alan. I'm going to be showing you the new Q today. So I'm really excited to see it. So let's just go straight into the unboxing. We're going to start with the stuff on the bottom shelf first. And first up for the software, I see we have 3 USB drives included. And these will have instructions for the installation and where to find support for the system. The license dongle will let us run the 2020 GOM Spec suite. So we're going to use this later, and I'll leave it with the controller. We also have information about the calibration artifact and the VDI accuracy test for the sensor. In this folder, we have more traceability information about the calibration artifact and the VDI test. We have the information for all the measuring volumes. Next up, we have the actual calibration panel. And as you can see, it's a white background with black dots. And this helps the sensor orient itself and also helps us when we're changing measuring volumes. We also have this nice stand for the panel. So what we do, if we wanted to calibrate, we set it straight up. Now the magnet's pointing up. We'll take the panel out, set it on, and you're ready to calibrate. And we also have this nice toolkit. So we don't use these a lot day to day because we don't need tools to change measuring volumes, but these are nice to have. We have reference points of different sizes, so these will work well for different parts and different measuring volumes. We also have room for 2 additional measuring volumes on top of the one in the sensor. So each measuring volume will have 2 lenses. And we'll also have a projector for each of the measuring volumes. Onto the top shelf, we have our automated rotary stage. This is called the GOM ROT 350. And with this, you can bring automation with you anywhere you go, and it'll speed up your scanning process. What you do is you just place a part in the middle, just spin it around, and it'll make the process nice and easy. And lastly, we have the Q. As you can see, it's a very sleek sensor, very lightweight. It's a cute sensor. It's my favorite part about it. It's dust-proof, splash-proof. And you can see it has protected optics. So it has a housing for all the cameras in the projector. In this case, we're going to set it on an industrial camera stand, but if you order it with a carbon fiber tripod, then that'll fit in the case as well. We're going to hook up the Q into the controller with the power cable here. We have a connection for the fiber optic as well. We'll plug the controller into a wall power source. And then tucked behind here is an on and off switch. It's going to flip it to on. And that's going to start up our Q. Now if we open up the controller, you see we have room for our laptop as well. And the controller is going to hook up using a Thunderbolt cable. And in the case, we have 2 extra cables to hook up the ROT 350. We have this USB adapter for the laptop. And we have a power cable, which you're going to plug into the same power strip. So we'll hook this into the back of the rotation table, and onto the power strip. And with this USB adapter, we'll be able to control the rotation straight from our laptop. Now that we hooked it up, it's getting warmed up, it's getting ready to go. And the nice thing about this system with the camera stand, it's a very portable system, very lightweight and easy to move around. And this is really nice in a machine shop setting, for example, because if you have a large part, or if you have a heavy part that you want to measure on the machine fixture, you can bring the Q to the part, instead of having to bring the part to the Q, like you would have to do with the CMM. You can see in the casing, we have 2 8 or 12 megapixel cameras. And in the center, we have an LED blue light projector. It's a very powerful light source, and it helps us do really well with dark surfaces. It also has the triple scan principle, so it's going to collect a lot of high quality data really quickly. And with the fiber optic connection, the data transfer is going to be lightning fast. So your scans are going to come in really quickly as well. In the next segment with Miles, we're going to combine this with the GOM ROT 350. We're going to see how fast the Q can collect quality data in combination with the automated rotary stage.
Today we have the system in a manual configuration on a carbon fiber tripod, and we're scanning a die-cast gearbox. One of the strongest features for this type of scanner is the ability to change your field of view. This lets you adapt the system to your specific measuring task by choosing the resolution and accuracy that's necessary. For this part, we're using the largest field of view that's available on the ATOS Q, which is 500 millimeters. Using this remote control and the manual rotation table, it makes scanning fast and easy. For scanning this part, I've put some reference points on the turntable, and that allows us to move the part or the sensor between the scans, and the software can automatically align them together. Also, the ATOS Q is a very fast sensor, and we're capturing up to 12 million data points per scan. The ATOS Q takes advantage of all of the latest GOM technology. This includes the triple scan functionality, which allows us to capture data in even hard-to-reach areas. Additionally, the system uses a fiber optic cable connection, 2 fast cameras, and the latest GOM fringe projection techniques in order to ensure that we have very accurate scan results. Now that we've seen a quick overview for how the ATOS Q captures detail on a complex part, let's take a look at some evaluation in GOM Inspect software. The result of the scan is an accurate digital copy of the part. Even these very difficult to reach areas that we can see here are captured easily using the triple scan technology. In terms of resolution, this is what you can get from the ATOS Q using the 500 millimeter field of view. GOM Inspect allows you to create color deviation plots, do section inspections, check your feature locations, and do full GD&T analysis. An extensive set of alignment features, measuring principles, and reporting tools make this a very complete package. Also remember that GOM Inspect is free to use, so it's very easy to share your inspection results within your project team. So now we've had our first look at an overview of using the ATOS Q for scanning a standard size part. Now let's take a look at a second setup of the system and talk about some more details of the ATOS Q. The ATOS Q comes in 2 different versions. There's a 12 megapixel version and an 8 megapixel version. You'll also notice how small the system is. The ATOS Q sensor head weighs only 4 kilograms, which is just under 9 pounds. This makes it very easy to take it with you to the job site. Another benefit for the ATOS Q is that it comes with 5 different measuring volumes. There's a 100, 170, 270, 350, and 500 millimeter variations. For the die-cast gearbox earlier, we used the largest measuring volume at 500 millimeters. This plastic part here requires more resolution than we had for the part that we scanned earlier. Therefore, I switched the measuring volume out to the 350 millimeter field of view and recalibrated the system. To make scanning even easier, I've set up the part on the GOM ROT 350 automated turntable. The GOM ROT 350 is controlled in the GOM software, so we can select 8 measurements here and start the scanning process. As we scan the part, you can see the data being built up on the screen as we go. You can see here just how fast and easy it is to scan with the ATOS Q in this configuration. Now that we've finished measuring the top side of the part, we need to flip the part over in order to capture the bottom side. To help us align the top and bottom scans together, I've put some small reference points on the side of the part. These allow the software to automatically combine the top and bottom halves of the part together. The result that we'll see later is going to be the high detailed mesh of the entire part. So now let's start scanning the back side. The blue light that you see projected on the part comes from a very sophisticated light source. This projection technique was developed by GOM to produce a very low noise data. This also produces a uniform speckle-free light. This light source ensures that we have the most accurate and repeatable data possible. So now both scans are finished and they're combined together in the software. So it's time to take a look at the results. Here's our scan result. We now have a high detailed mesh which is describing all features of the part. Since we scanned both sides, we have the complete digital twin which we can join with its CAD file to start the evaluation. The first step is the alignment of the part to the CAD model. Both overall alignments and local alignments are possible inside GOM Inspect. Again, since we scanned the part from both sides, we can now analyze the thickness of the part and verify if the thinner areas are to specifications. The design of this part requires for a lot of GD&T style inspections. These are calculated on the scan data, describing the part in great detail and offer a very accurate and realistic evaluation. Reporting of the full analysis is done in the reporting space. Even from a black part like this one, you can see how clean the results are. Remember that GoInspect is available free of charge and can be used to share all the data in a way as you see it here on the screen. So what if we want to scan multiple parts? We've already seen the scanning speed of the ATOS Q in this configuration, and we also know that the GoInspect software is parametric. That means that we simply have to add the second, third, or any subsequent scan data into our original inspection report. The software will then automatically recalculate the inspection and deliver you a full trend analysis across all of your parts.
So we've unboxed and set up the ATOS Q and also saw Miles give a demonstration along with some tech specs, features, and functionalities. One of the things that I love about my job is being able to spend time and get to know people, understand their story, and hear how they're using our technology to improve processes at their company. So I was able to spend some time with Brian from Solar Turbines. I'm really excited about this interview.
Thank you so much, Catherine.
You know, Brian, you've been working there for about, I think, 15 years. It's been a long time.
Yes, going on 18 years, actually.
18 years. Oh, my goodness.
In the middle of my 17th year. So yeah, been here for a while. I've totally enjoyed my career using this technology here at Solar, and it's actually moved my career quite well here.
Oh, that's so great. I love hearing that. You know, what kind of started you to get into engineering?
About after 6 years in the Navy, I got out and went right into aerospace, working on satellites for companies in Phoenix. And then moved to California and went into making medical implants, all of which had very extensive source inspections on both medical implants and the aerospace done by CMM and conventional means of inspection. And then I came to Solar approximately a little over 17 years ago.
And I know as far as data quality, what does that mean to you? Like, what does quality, you know, that type of measurement technology mean?
For me, the quality is everything. The more accurate you are able to collect data from a model and its actual condition, how it's manufactured, the better. The only actual perfect model is created in a CAD system. It's mathematically perfect. Mankind cannot make a perfect model. We cannot. The question now being is how accurately can we measure how imperfect it is? Not how good it is, but how far out it is based on what our design intent is. The design intent being shown through a CAD model, which is perfect. So the accuracy of this has allowed us to, with the tri-top system and how we do our scanning here, has allowed us to follow along on plus or minus 0.0001 to 0.0002 for tree alignments, that kind of stuff, fit and form issues, and doing multiple iterations of following a blade from inception to actual 3D printing, which we now use completely ATOS scanning on.
Yeah, and I know you measure a lot of airfoils, a lot of bliss. You know, Solar Turbines does a lot of power generation type engine components. So when you see this technology in your industry, what do you imagine kind of the future to be?
In the future, I see this integrating completely with the MBD. We need to get rid of drawings, and the only way to do that is literally MBD. And the entire enterprise of manufacturing worldwide would have to get on board to do that. And in a way, this is revolutionizing inspection and reverse engineering like CNCs would to conventional machining. So a picture's worth 1,000 words. I actually see conventional inspection techniques phasing out over the next several years and 3D metrology taking over almost all forms of inspection.
Yeah, we've been seeing the same thing. So from, the 17 years of my journey so far, I've seen first when I started, it was explaining the science behind the technology.
Yes.
And now it's been accepted and now it's trying to, you know, like give knowledge to people on why data quality differs because there's so many different type of metrology devices and our customers are always benchmarking and proving the accuracy and I guess I could call it maybe the stability in the process or just knowing that it's repeatable and it's a sound process. So with 18 years or so it's not easy to adopt new technology and it's not easy to change a process. But when you see something that can improve your company and the manufacturing process so much, you want to be motivated to try to make that change. But
yes.
Yeah, and you work with like a huge
the
company.
Technology sells itself. I've gone to many suppliers and taken this technology with me, and they want to know how we're going to look at something, and we would actually qualify a part on a machine using this technology that could not be taken off the machine because of inspection through restraint process, where it's got to be constrained. Well, how do we inspect something that's constrained that's 97 inches in diameter? Well, you use an ATOS system. And several times I've done something like that to qualify a part to bring in the solar. The company is this is amazing. Where do we get it? Who do we see? These people you see, and it sells itself. You cannot see this technology in action without being totally amazed. If you have any kind of background in manufacturing, whether you're a machinist or a deep burr hand or whatever, you'll know that you're actually replicating a physical part, and as close as we're able to replicate it, which is accurate enough for aerospace.
You were with us since it was a white light scanner, and then we've used LED technology for blue light. And exactly what you've been saying, when companies are transitioning from a more traditional type measurement system like a CMM to ATOS, a structured blue light scanner, you're knowing more about your part. You're not just picking out defined points. You're actually seeing what is going on surrounding that area. And so it's been such a powerful tool. And I think, you've had so much success with it. I'm excited for you. I can't wait. I know we discussed the potential of you being a guest speaker at our next innovation virtual conference.
I've always enjoyed those, yes.
Thanks, Brian, again for your time. We really appreciate it. And I can't believe it's been 18 years. Wow, time just flies. So please don't forget, everyone, use the chat. We are online live to answer any questions as we go. And at the end, we'll have a live Q&A and we'll kind of read out the frequently asked questions that we're seeing and go over, whatever details you'd like to discuss. So now next is Miles. He's going to be showing us how the ATOS Q can be used for small parts.
In this setup, we're going to talk about how you use the ATOS Q to scan small, high-detailed parts. The part that we have now is a precision graphite electrode, which is used for tool making. You'll notice here that we have the sensor mounted to the desk stand. This allows us to achieve the stability necessary to scan this sort of high-precision part. Another benefit to the ATOS Q is that for each and every measuring volume, the standoff distance is the same at 490 millimeters. This is because we have one fixed camera angle that we use across all lens sets. This makes any of the lens set changes from the smallest to the largest measuring volumes very fast and easy. With this part, we've changed our lenses from the larger field of views we had earlier down to a measuring volume which is 170 by 130 millimeters. This means that all 12 million of our data points are crammed in that small area. This allows us to get a resolution, or the minimum point spacing between 2 points on our mesh, down to as low as 30 microns. In this sort of setup, you could also use the smaller measuring volume of 100 millimeters or a larger measuring volume like the 270 millimeter. Just like with the larger fields of view, scanning is very fast and intuitive. The precision calibration of the ATOS Q allows us to maintain the necessary accuracy and precision for a part like this one. Both manual and automated rotation table solutions are available for this type of setup. The ATOS Q is also taking advantage of GOM's triple scan technology. That means for every sensor position, we're looking at 3 different viewpoints. The first thing the system's going to do is take a look at what it sees from both cameras together. Then it's going to look at the left camera independently and then the right camera independently, so each side can cover what the other one misses. In order to do this, you need to have a precision calibrated 3D camera. The system will automatically combine all 3 different viewpoints for each scan, and this allows us to capture even hard to reach areas easily. So let's take a look now at the data that the ATOS Q got on this part. Here's the resulting mesh from that scan, and just take a look at how much detail we can get on that part. We can see here that the software automatically reduced the number of points on the flatter areas of the part, and on the curved areas we still get the maximum amount of detail. With the 170 millimeter measuring volume, even the smallest shape deviations will become visible on this electrode. We talked earlier about the triple scan principle. Here we can see the results from this technique. It's a very powerful feature of the ATOS Q, which allows us to scan deep into narrow pockets. The last thing I want to show you here is a color deviation plot of the top of the electrode. If you look on the right-hand side, you'll see that the total range here is just 10 microns. Now it's very easy to verify whether this electrode can be used for the EDM process or see if it has to be improved first. Now we've had a look at how we use the ATOS Q to scan small precision parts. You'll also notice that the finish on this part is a dark black, and even this sort of surface we can scan quickly and easily with the ATOS Q.
Thanks, Miles, for showing us the Q on the desktop stand. It's really cool to see get the detail on the small part like that. Now we've seen the desktop stand, we've seen the tripod, we've seen the industrial camera stand, but one more option our customers ask about a lot is automation. Because automation can make a big difference in throughput and repeatability. And with the Q, we can do automation on the ScanBox 4105. So let's go back to Miles, and we're going to see it in action.
GOM is very well known for its series of ATOS ScanBox systems. And now with the ATOS Q, there's a new addition to the family for automated inspection. I'm standing here in front of the ScanBox 4105. This system is very easy to install, requiring only a standard single-phase power socket. The ScanBox 4105 can hold parts weighing up to 100 kilograms with a maximum size of up to 500 millimeters. Now I want to walk you through the entire process, starting with programming the robot, then scanning the part, and then taking a look at the final inspection results. But first, we need to go into the GOM Inspect software and look at a function that we call Smart Teach. ATOS ScanBox systems are delivered with the Virtual Measuring Room, or VMR. The VMR is an extension to the GOM software which allows us to control the automation device. You can see the ScanBox here inside the VMR, so let's first start with loading the fixtures and CAD file. Linked to the CAD file is an inspection plan. This could be loaded as PMI data straight out of the CAD file, or could be created by the inspector. Now that the software knows which features need to be inspected, we just need to start the Smart Teach procedure. In just a few seconds, all of the necessary sensor positions to scan the part are calculated. We can then finalize the procedure with an optimization, which will define the fastest route covering all the needed sensor positions. We're now ready to start the robot and let the ATOS Q scan these parts. ScanBox systems come with a simplified kiosk interface, so all I need to do is walk up to the touchscreen and press the start button. The ScanBox is now going through the program we just created using Smart Teach. Here, the parts are mounted in a multi-part fixture and they rotate around using the rotation table. The combination of the robot and the rotation table makes it possible to access all areas. The standoff distance of 490 millimeters makes it very useful for measuring parts with some fixturing around them. While we're scanning, let me tell you a few more things about the ATOS Q. We developed this sensor for industrial use. Next to the protected optics, it has a fast optical cable connection, which ensures a reliable data transmission. The system checks itself as well. In case of a sudden vibration during scanning, it will be repeated automatically. Even the sensor calibration is checked constantly to ensure that you'll always get an accurate result. So now the scanning is finished and the software has automatically calculated the results. So now let's go take a look at the kiosk interface. As the operator, I can get a nice overview of the inspection results. I can see the overall shape distortion and look at the trim deviation. Then at the end, I have the ability to decide whether or not the part can continue on through the production process or needs to be worked on some more. Easy to install, easy to operate. The ATOS Q inside the SCADBox 4105 is your system of choice when it comes to speed for inspecting parts up to 100 kilograms or 500 millimeters in size. The VMR with SmartTeach takes all of the hassle from robot programming. Automated inspection is easy and accurate with the ATOS Q.
All right, so thanks, Miles, so much for showing us the ATOS Q on the 4105. So what we've seen are more and more companies transition towards the automated path for increased repeatability and also higher throughput. With me now, I got Josh, who is our engineering manager at Capture 3D. We worked together many, many years. Josh, how you doing today?
Doing great, Kat. How are you?
I'm doing good. Thanks so much for spending time with me. So I think one of the things we've been talking about today is the new ATOS Q, and I kind of want to get your input. What did you think when you first saw it?
When I first saw it, the portability, it's amazing. You probably saw it with Alan walking through the building in the other video. The different volume sets, just like our high-end systems. The ability to put it on a robot like you saw on Miles. Just such high accuracy quality in such a small 9-pound package. It's pretty amazing.
It is. Yeah, it is. And, you know, the engineering team that you manage, you work directly with our customers, you know, from the demo through either proof of concepts, benchmarking, all the way to the installation and training. And so that your team is right next to our customers. What do you see as far as what is an important problem that we might be solving with the technology?
Oh boy, there's a lot of problems we saw with the technology. You know, we're integrated in a lot of full production SPC type applications, fully automated. But we're also manual systems with root cause analysis. You know, one area that I remember was an automotive company that had some vehicle issues, and I was actually there in their metrology lab. But they had some vehicles that had some fit and finish issues coming off the line. They were able to pull it in to the scan area, scan the area, peel some panels back, continue to scan, and within maybe 30, 35, 40 minutes, they had all the department heads in one room with a color map and all of the components that were causing the possible issue, and they were able to dial down to a very specific area or very specific department. And then they were able to make the change and fix the issue very quickly. Within an hour, they had a goal to go to.
That is amazing. You know, when we talk about how much data we're able to capture and how quickly you can make a good decision based off that data. So it really minimizes that time.
Yeah, they were able to take that data and go right back to it was actually a die issue. They were able to go right back to the die issue to fix the die, to move the panel a little bit during the stamping process. So it was quite amazing.
That is great. And then now they have this data even for the future. So future design, development, you know, it's like we all learn from the lessons that we've been through, and so that we can, you know, create a better process. So with your team, you know, one thing is a lot of customers ask us for demos. So what can they expect from, you know, engineering as far as working with them to see the technology?
Sure. I mean, all our engineers are experts at the hardware and software. You know, we have the luxury of having only one software that we use and a few hardware components that we handle. So we were able to become very good at showing those to our customers. But also we have a vast knowledge of experience in all the industries, from automotive to aerospace, to plastics, to castings. And with that, when we show our customers, we give them the comfort that anything that they're going to need in the future process improvements, that we can support them with that. And then during demonstrations, usually that really comes out, and that really gives them the confidence to, go with us. That's for sure.
Yeah, and I absolutely love it. Just the fact how close we work with our customers. And I think it's been great. Your team has been doing a fantastic job. I know I've taken a lot of your time, but I just want to say thank you so much for your time today. And yeah, thanks for that insight on the ATOS Q. Thanks everyone for joining us today. So that kind of concludes this section, and we want to move over to the live Q&A. So please, utilize the chat. We are going to be here for you. I think one of the most interesting things that I learned about the Q is I'm super excited about how fast and accurate it can measure small to medium-sized parts. And when we look at the GOM technology for data resolution and clarity, it's amazing. So see it firsthand, schedule either a virtual demo with us or an on-site demo. We also offer services for a proof of concept. So our team is readily available. We hope that you enjoyed this event. We would love to hear from you all, and we hope that you stay safe. Thanks so much. Bye.
So I believe we have about 10 minutes for the Q&A session, so let's get started. All right, so do we have Ron and Catherine?
Hi, guys.
Hi. All right, so then the first question I believe is for Ron because it's more technical. And the question came from Steve. He said, Q and software look nice for engineering. How accurate is it? And this accuracy question was also asked by Michael. Ron, would you like to take that?
Steve, Michael, great question. One we receive quite often. Accuracy depends on your part, the ATOS sensor used, and the measuring volume or the field of view. However, we achieve single-digit microns. As you saw with Alan unboxing the ATOS Q, each measuring volume comes with a VDI certification and documentation. When you heard Catherine's interview with Brian, an actual ATOS user, they are achieving 1/10 to 2/10 of an inch or 2.5 to 5 micron accuracy with their applications. In regards to the accuracy of the GOM software, it's independently tested and certified by NIST and PTB. Also, we offer proof of concept projects to prove out our accuracy capabilities on your part.
So another good question that I got, so I believe this could be the question for Catherine. Charlie said, really nice. We have an older CMM that they have been thinking about replacing. What's the cost for this?
Great question. So Charlie, the starting price is $60K for the ATOS Q, but that includes not only the technology, but the GOM Inspect Suite software for the basic inspection. It includes shipping, e-training, and 1 year of hardware support. There's various other configurations. You guys saw Miles Ann Allen showed different settings all the way up to a 4105, and it is compatible with the GOM Scan Cobot. And so, but that 60K is the starting price.
Okay, nice. All right, moving on to the next one, we have Emma who said, hey, Capture 3D, nice to see the new product. We have an older ATOS and we use it every day in the shop. So she said it's really become their workhorse, and are there any upgrade incentives? And I think that could be you, Catherine?
Yeah, I don't mind taking that one. So, hey, Emma, thanks for joining us today. I've been seeing the chat throughout the event, and it's really nice to see all of our customers and new people come to the technology, to the event. But to answer your question, it really depends on your current system. But yes, we do offer upgrades, trade-ins. So what I would do is email info@capture3d.com, info. Go ahead and send us your dongle ID or your serial number, and then we'll send you out a quote.
All right, thank you. So actually, there are quite many technical questions. So I'm going to start with the first one. Andy said, ATOS Q looks very versatile. It's great that you can use it both manually and automate it. Do you need a special configuration to automate your scanners? Ron?
So thanks, Andy. Another great question. No special configuration. The flexibility of the ATOS Q, you can use it as a manual solution and then take it and place it on a scan box, and it's a plug-and-play solution for automation. Very flexible, very capable.
Mm-hmm. Yeah, so right now we have 5 minutes left, so I'm gonna get a few more questions, and another one I'm seeing is probably Kat. Okay, moving on. How can we download your free inspection software? I know Justin answered. Thank you for that, and he's included the link to download the software. But would you like to go over the training and how is this offered? Kat?
Sure. I don't mind. Yeah, and thanks, Justin, for helping out with that question. So yes, there's a link to download the new GOM Inspect Suite software. It's coming out, I believe, in August. And there have been, every year GOM makes tremendous, updates to it based on what our customers are looking for. So there is training. We actually offer free virtual training course. There's actually one in July. Sonia, I think it's like
28th through 30th.
Okay. So yeah, and that's completely free. So GOM Inspect is a free software to use. I believe it doesn't include the parametric features, but it has comprehensive features. So go ahead, download it, try it out, and enroll in the July course. It's 3 days, 2 hours a day, and it's live with our AEs, with our application engineers.
Okay, right. So thank you. And I also see like a lot of technical ones asking about, for example, Steven is asking how to scale larger parts with ATOS Q and tri-tops, because during Miles' presentation, he had mentioned about tri-top being used for larger parts. How do we scale that?
So I'll take that one. So tri-top would be used on a larger project to maintain overall part accuracy. So with the tri-top system, we do a short session collecting the reference points over the entire large part. And then you can start scanning with ATOS. So this would increase the accuracy overall part size, and also can decrease the amount of scan time needed by decreasing the number of scans. So combining ATOS and TriTop is a big plus.
Okay, thank you. Another good question here is that from Jordan, and he asked, for scans on larger parts that require large standoff distances, would you recommend an ATOS 5 or triple scan model? So obviously this user is familiar with both of our models and scanners.
So for me?
Yes.
Go for it, Ron.
All right. So depending on the standoff distance requirement, all the ATOS systems are working at a fixed standoff. The ATOS 5 does have a larger standoff distance. So it would depend on how you're defining a larger standoff distance requirement.
Okay, thank you. Another one is, okay, so Kurt said sealed dust proof, that this is a question regarding that. What rejects the LED heat? Is it a removable module, or is it passive, or does it have a fan? Can it be cleaned?
So the components for the ATOS Q system, like some of the other ATOS, especially the ATOS 5, these are internal components. They're sealed and protected, and there's a heat exchanger and an external fan.
Mm-hmm.
So the only external item would be the fan. And yes, you can clean it.
Okay, good. So we do have another question. It says, we have the ATOS 5, it's awesome. Still need more training on it and the software to gain the full potential of the scanner. So would you like to answer to that, Catherine?
Yeah, I don't mind. I'll take the less technical ones, I guess. I'm just kidding. So yeah, I'm loving the chat, honestly. Like, I just love all the participation and the interaction. So thank you, everyone. To answer your question, the ATOS 5 is different than the Q. So although the design intent and how it looks is, derived from the 5 actually has a brighter light source. We have more volumes, and it is different technology. So I would say, test out your application, your part, and obviously the price varies too. So hopefully that helps.
Okay. Just to add to that, so this was regarding the needing a more training. So we do offer virtual training at the moment, and also physical training at our four of our locations. So if you're interested in learning more about acquisition or inspection training, please reach out to us and we'll get you up and running. All right, so another one was regarding the okay, so it's from Mizan Noor. I'm sorry if I'm not pronouncing your name correctly. For Ron, is it possible to integrate the robot in the CNC environment to scan the part in order to locate it?
All right, so CNC related question. Yes, with a couple of ATOS scans, the data can be used to position the part within the CNC. We have aerospace and automotive customers using our technology for adaptive machining. They use ATOS to automatically verify the machine part while it's still in the CNC. And we partner with machining software companies to take our data back in for automatic reprogramming.
From Samia, I think most of our team members and our guys helped out answering this question, but for those who haven't seen the chat, Samia asked, how long does it take to change between the lenses?
So Samaya, another great question. After a quick change of lenses and system warm-up, the calibration process is only 8 to 10 minutes. What's really nice, the ATOS software guides the user through the process step by step. Total process, including system warm-up, bringing the lenses up to temp, about 30 minutes.
Sonia, do you mind if we also address, it looks like a couple people, because I have it on my mobile device too,
okay,
are asking about, scanning translucent, transparent
right,
plastic and silicone parts. Okay. So, it's still an optical metrology technology. So for transparent parts, we'll need to spray. Now, For those that aren't aware, we are also ASUB distributors, and ASUB is a company that makes a spray that disappears. It vanishes, Ron, after so many hours, right?
Yeah, about 2 to 3 hours.
Yeah, so we've actually have continuously ran out. So we've actually ordered a huge, like multiple pallets of it because it's been such a popular product to use for the disappearing spray. So yep, I see Pedro's comment. It's awesome. It is. So it's been a great product to use for those transparent parts.
Leroy said ASAP is the best.
I know, I see it. I love it.
I just realized we've been going through the questions in chat, and I realized we're actually past our 10 minutes for the Q&A session. So with that, maybe I'll take the last question. Would you like to pick a question that you jotted down?
So we do have a question. I know you guys can't see who the host is, but it's actually Jason, our digital marketing manager. Jason, do you mind just turning on your camera real quick just to show your face? Hi. Okay, great. So it's been really a team effort to put this program together, and really nice job, Jason, not only our digital marketing manager, but also our cameraman. So thanks so much, Jason. So he's the host and he's been getting questions. I've been seeing it on my mobile phone. So the question is, also, can the deviation data export Excel spreadsheet? Ron?
Yes, we can export the CMM type tables, and we also like to add the color plot, the easy to read, easy to understand deviation reports. The GOM software is very powerful. It's one of the favorite things that our customers like about our ATOS systems. If you're interested in seeing a sample inspection report of all the features, just reach out to us. We'll email you a copy. We have GD&T and trend capabilities available in our software.
All right, then thank you guys so much. With that, we would like to end our event here, and we hope everyone got something out of this launch event. If you have any questions that haven't been answered, please reach out to us at info@capture3d.com, and we'll be happy to further help you out. And thank you very much for attending and giving us a chance to produce something like this and network with you all and answer some of your questions. So it was a great 1 hour to spend with you all, and we hope everyone has an amazing the rest of the day. Thank you.
Yeah, thanks everyone. Also, the PowerPoint too. We didn't want to give like a typical PowerPoint to everyone. So we do have that for download. Email us.
Yep. Thank you.
Bye guys.
Thank you guys. Have a good one.